Welcome back to Omni Eyes. Today we travel back hundreds of millions of years to uncover the ultimate secret of ancient vision. Prepare yourself for episode 67, where we dive into the primordial oceans to meet a truly fascinating extinct creature, the trilobite. Long before dinosaurs roamed the Earth, these heavily armored marine arthropods dominated the ocean floor with absolute supreme authority and remarkable resilience. They survived multiple mass extinctions, adapting to rapidly changing environments over an incredibly vast and turbulent geological timescale of ancient planetary history. But their most astonishing evolutionary achievement was not their tough exoskeleton, but rather the highly sophisticated biological technology hidden within their eyes. While modern animals rely on soft tissue lenses that degrade over time, trilobites engineered a completely different and revolutionary optical survival solution. They possess the very first complex eyes in the entire history of life on Earth, granting them an unprecedented visual predatory advantage. These ancient pioneers developed a visual system so radically unique that modern human scientists are still marveling at its sheer structural perfection. To truly understand this biological miracle, we must zoom in closely on the microscopic architecture of their incredibly well-preserved fossilized eyes. Imagine an eye constructed entirely out of solid rock. This is not science fiction, but a certified historical reality of ancient biology. Trilobite lenses were forged from pure calcite crystal, a naturally occurring mineral compound known for its exceptional hardness and perfect optical clarity. Because their lenses were made of solid crystal, they never experienced the cellular aging process that slowly blinds modern animals over time. A trilobite could live its entire life without ever suffering from cataracts, cloudy vision, or any age-related optical degradation whatsoever. This extraordinary phenomenon is scientifically classified as inorganic optics, a rare evolutionary pathway where living organisms utilize non-living minerals for sensory perception. The rigid structure of calcite meant that the trilobite could not dynamically change the shape of its lens to focus on objects. Instead, they evolved a highly specialized internal bowl shape that naturally corrected spherical aberration, providing perfectly sharp vision at multiple focal distances. This dual lens configuration is remarkably similar to the complex optical designs created by 17th century physicists like the legendary René Descartes. Yet, the humble trilobite had already perfected this exact mathematical optical formula hundreds of millions of years before humanity even existed here. Let us take a moment to visualize the world through the unblinking, crystal-clear perspective of this magnificent ancient ruler of oceans. Sunlight piercing through the prehistoric waves would strike the faceted crystal arrays, breaking the underwater environment into a mosaic of sharp images. Each individual calcite lens captured a tiny fragment of the surrounding environment, feeding highly precise visual data directly to the creature's brain. Predators approaching from above or behind would be instantly detected by the wide panoramic field of view generated by these compound eyes. The absolute rigidity of the crystal lenses provided unparalleled protection against the intense physical pressures found at the bottom of the sea. Soft tissue eyes would easily deform under such crushing oceanic depths, but the trilobite's stone eyes remained perfectly intact and fully functional. It is a profound paradox that a living, breathing creature relied so heavily on cold, dead mineral formations to navigate its world. This perfect fusion of biology and geology represents one of the most fascinating evolutionary experiments ever conducted by nature on our planet. As we examine these fossilized lenses under modern electron microscopes, we uncover a breathtaking level of precision that rivals modern manufacturing techniques. Every single crystal was perfectly aligned with the creature's visual axis, ensuring that incoming light rays were transmitted with maximum possible efficiency. If the crystal alignment were off by even a fraction of a degree, the trilobite would suffer from severely distorted double vision. But nature does not make such careless mistakes. The evolutionary process refined these crystalline structures into absolute optical perfection over countless generations. Today, modern optical engineers and material scientists are looking back at the trilobite for inspiration in designing the next generation of lenses. We are currently trying to replicate the concept of inorganic optics to solve some of the most difficult engineering challenges of today. Imagine sending a highly advanced robotic rover to explore the harsh, abrasive, and unforgiving surface of Mars. or other distant alien planets. Traditional glass or plastic lenses can be easily scratched by extreme dust storms, degrading the visual data transmitted back to our scientists. However, if we engineer camera lenses using ultra-hard crystalline materials inspired by trilobites, they could easily withstand these brutal extraterrestrial conditions. These biomimetic lenses would never cloud over time, ensuring that our multi-billion-dollar space missions maintain perfect vision for many decades. The applications extend far beyond space exploration. Deep-sea exploration vehicles also require optical systems capable of surviving immense underwater hydrostatic pressures. By studying the structural geometry of trilobite eyes, engineers can design underwater cameras that never crack or deform under crushing oceanic depths. This incredible crossover between paleontology and modern engineering proves that ancient fossils hold extremely valuable secrets for our future technological advancement today. The trilobite teaches us a highly counterintuitive lesson about material science. Sometimes, rigid and hard materials are vastly superior to soft ones. In the biological world, flexibility and adaptability are usually considered the ultimate keys to long-term survival and evolutionary success on Earth. But the trilobite boldly defied this conventional wisdom, proving that uncompromising rigidity can also provide a massive evolutionary advantage in certain environments. Their stone eyes were an uncompromising fortress against physical damage, chemical degradation, and the relentless passage of time in the primordial seas. Even today, hundreds of millions of years after their extinction, their crystal lenses remain perfectly preserved in the global fossil record forever. We can look through the exact same lenses that a living creature used to navigate the ocean floors millions of years ago. No other extinct animal has left behind such a perfectly intact and functional sensory organ for modern humanity to study and admire. It is a deeply humbling experience to realize that human technology is only just beginning to catch up with ancient biological engineering. The intricate crystalline matrix of the trilobite eye challenges our fundamental understanding of what living organisms are truly capable of achieving naturally. As we delve deeper into the microscopic world of inorganic optics, we discover a realm where biology and geology become completely indistinguishable. The calcite crystal is not merely a transparent rock. It is a highly ordered, mathematically precise structure born from the Earth itself. When a trilobite absorbed calcium carbonate from the surrounding seawater, it meticulously constructed its vision system, molecule by molecule, with astonishing precision. This biological manufacturing process required an immense amount of metabolic energy, but the evolutionary payoff was undeniably worth the massive biological investment. With their crystal-clear vision, trilobites could easily spot small prey hiding in the murky sediment of the ancient ocean floor environments. They could also detect the subtle shadows of massive, terrifying apex predators swimming silently above them in the sunlit upper water column. Their stone eyes were the ultimate early warning system, allowing them to survive in a fiercely competitive and highly dangerous prehistoric ecosystem. Some specialized species of trilobites even evolved highly elevated eyes on long stalks, functioning exactly like periscopes on modern military submarine vessels. These periscope eyes allowed them to remain safely buried beneath the ocean sand, while keeping a vigilant watch for any approaching danger. Other species developed massive wraparound eyes that provided an incredible 360-degree field of view of their underwater surroundings. Regardless of the specific shape or size, every single trilobite eye was fundamentally powered by the same miraculous calcite crystal optical technology. The sheer diversity of their visual adaptations is a powerful testament to the incredible versatility and effectiveness of pure inorganic optical systems. However, the very same rigid armor that protected them eventually became a significant liability when the global environment began to change drastically. During the catastrophic Permian extinction event, massive volcanic eruptions drastically altered the chemical composition and acidity of the Earth's ancient global oceans. As the oceans became increasingly acidic, the calcium carbonate structures of the trilobites began to dissolve, rendering their crystalline eyes incredibly vulnerable. The ultimate biological armor that had guaranteed their survival for hundreds of millions of years ultimately contributed to their tragic final downfall. Despite their eventual extinction, the legacy of the trilobite lives on in the fascinating fields of modern paleontology and advanced material science. They serve as a powerful reminder that evolution is an endless process of experimentation, constantly pushing the boundaries of what is possible. By studying their fossilized remains, we gain invaluable insights into the complex history of life and the intricate mechanics of sensory perception. Furthermore, their inorganic optical systems offer a highly promising blueprint for developing revolutionary new technologies that could shape our own human future. Imagine a future where our most advanced cameras and telescopes are equipped with synthetic calcite lenses, modeled directly after ancient trilobite eyes. These biomimetic devices would possess unprecedented durability and optical clarity, allowing us to explore the darkest depths of space and the oceans. We could capture stunningly detailed images of distant alien galaxies and uncharted underwater trenches without ever worrying about lens degradation or damage. The ancient trilobite, a creature that has been dead for millions of years, could ultimately help humanity unlock the mysteries of tomorrow. This is the true beauty and power of scientific inquiry. The ability to connect the distant past with the rapidly approaching future. Every fossil buried in the Earth's crust is a tiny time capsule, holding profound secrets waiting patiently to be discovered and understood. The story of the trilobite and its crystal eyes is a perfect example of how nature often engineers the most elegant solutions. While human engineers rely on supercomputers and complex algorithms, nature utilizes the relentless, unforgiving forces of natural selection over immense geological timescales. The resulting biological designs are often vastly superior to anything we could possibly invent in a modern, state-of-the-art laboratory. As we continue to face unprecedented global challenges, we must increasingly look to the natural world for inspiration and innovative survival strategies. The answers to our most complex engineering problems may already exist, hidden within the fossilized remains of long-extinct prehistoric ocean dwellers. By embracing biomimicry, we can harness the ancient wisdom of evolution to create a more sustainable and technologically advanced human society today. The concept of inorganic optics is just one small example of the incredible untapped potential lying dormant within the global fossil record. Who knows what other miraculous biological technologies are waiting to be unearthed by dedicated paleontologists and visionary material scientists in the future? Perhaps we will discover extinct organisms with naturally occurring superconducting nervous systems, or biologically engineered carbon nanotube skeletal structures hidden in rocks. The possibilities are absolutely endless, limited only by our scientific imagination and our willingness to explore the deep, mysterious history of life. So the next time you hold a piece of limestone or gaze upon a sparkling calcite crystal, remember the magnificent ancient trilobite. Remember the incredible prehistoric creature that literally looked at the primordial world through eyes made of solid, unbreakable, and perfectly clear stone. Let their fascinating evolutionary journey inspire you to view the natural world with a renewed sense of absolute wonder and profound curiosity. Because even the most seemingly insignificant fossil can hold the key to revolutionizing our understanding of science, engineering, and our own existence. The tale of the trilobite reminds us that true innovation often requires us to look backwards before we can confidently move forwards. By studying the ingenious survival strategies of the past, we can better prepare ourselves for the unpredictable challenges of the distant future. Inorganic optics is not just a quirky biological anomaly. It is a profound testament to the boundless creativity of the evolutionary process. It demonstrates that life will always find a way to adapt, utilizing whatever raw materials are available in the surrounding physical environment. Whether it is soft organic tissue or hard inorganic crystal, nature continuously molds matter into incredibly complex and highly functional living structures. As we reflect on the remarkable story of the trilobite, let us deeply appreciate the incredible fragility and immense resilience of life. They ruled the oceans for hundreds of millions of years, yet they were ultimately erased by forces completely beyond their physical control. Their dramatic rise and tragic fall serve as a stark reminder of our own vulnerability on this dynamic and ever-changing planet. But their enduring legacy, perfectly preserved in stone, offers a powerful message of hope and inspiration for future generations of scientific explorers. The crystal eyes of the trilobite continue to shine brightly across the vast, dark abyss of deep geological time, guiding our way. They challenge us to look closer, to think differently, and to never underestimate the profound wisdom hidden within the natural world entirely. We have now completed our fascinating journey through the ancient seas, exploring the miraculous inorganic optical systems of the legendary extinct trilobites. From the crushing depths of the primordial oceans to the cutting-edge laboratories of modern material science, their profound impact remains undeniable. The lessons we have learned from their crystal lenses will undoubtedly shape the future development of advanced optical technologies for many decades. Whether we are exploring the dusty surface of Mars or the darkest ocean trenches, the spirit of the trilobite will accompany us. Thank you for joining us on this incredible scientific adventure through deep time, biology, and the fascinating world of advanced inorganic optics. If you enjoyed this episode, please subscribe to Omni for more mind-bending explorations of science and history. See you soon!